In this session, we're going to talk about lipids. Now, unlike polysaccharides, lipids are not polymers, so they will not be made from like a lot of monomer molecules to form up like a big lipid. No. They are not like polymers. Now, some of the uses of lipids which are very familiar and that comes to mind is that lipids, they usually act or they are used as an energy. There is as an energy storage, and you discover as we go on why they are used as an energy storage. Then lipids also help in what we call heat, insulation. They insulate us. Then the largest function of lipids, I would say they are mostly used in form or to form membranes of plants mostly. You see as we proceed how lipids are used as like in membranes of plants. Then the other thing is that lipids also acts as steroid hormones. That can be one of the functions of lipids. Now, if we have a structure, let me say have a carbonyl group connected to an OH like that, and you've got this molecule, let me say, yeah, it's going like that. These are carbon, this is carbon, you have an H there. Okay, let's say this is H, you have H there. Okay, so this can be a typical structure of a lipid. Now, this group which is here is called the polar head. Then this chain that goes down that side, or this chain will be called the nonpolar part. Now you see that this chain which is nonpolar, it has a lot of carbon molecules, so it's very nonpolar. It can be like dissolved in water. Then on the other part you have this the one that has an OH, and this one, because it's able to form like hydrogen bonds, so it can easily be dissolved in water. So this part which doesn't which cannot dissolve in water is called the hydrophilic, the hydrophobic actually. Phobic to mean it's water hating. Then the one that likes water, this one, it will be called the hydrophilic, your hydrophilic head. Now, the structure of a lipid, of the structure, the polar hydrophilic head is connected to a non-polar hydrophobic or carbon tail like we saw. Now, lipids are called, or they are amphipathic. Now, you must really know this term, because it's what distinguishes lipids from other biomolecules. So I find that amphipathic, like amphibian, those animals which are both found on land and in water. So even lipids, amphipathic in this to mean a molecule that has both hydrophilic part, a hydrophilic, and a hydrophobic and hydrophobic part. So that's what we're talking about. So lipids are amphipathic molecules. Then there are two classes of lipids that you need to know. The first class, they are called the simple lipids. Now these ones are lipids like the common ones these are fats. Fats are the common, you know, simple lipids, because they're just made from, you know, when you combine a glycerol in this case is just an alcohol, you know, plus a fatty acid, like that. That's how fats, you know, are made. That's the most common of simple acid. So we find that in fats, these ones will contain, you know, a carbon, they contain an oxygen, they also contain a hydrogen. Okay, then we also have another class of lipids. These ones are called your complex lipids. Now, just by the name, you're able to tell that you know, these complex lipids, they are really larger molecules in terms of, you know, so these ones usually contain 4 active ingredients. So they are going to have a fatty acid. They can also have a glycerol. Not only that, they might also have a phosphate. A phosphate group. You see, like, we'll be talking like phospholipids. And you know, they can also have a chlorine group. They can also have a polar molecule. So these ones are really large, even just the name itself, like complex. So now we've said, you know, fats, the simplest form, are made, you know, from, you know, fatty acids, you know, and glycerol, which is an alcohol. So now let's just talk about fatty acids for a while. So fatty acids, let me just abbreviate them as Fa. Now there are 2 types of fatty acids that you are supposed to know. You know, the first one is called the saturated fatty acid. Then the second one that you are supposed to know is you know, an unsaturated fatty acid. So now the difference between these two is that one has a double bond, or the other one doesn't really like have you know, double bonds. So in this case, the one that doesn't have a double bond is you know, a saturated fatty acid. So it only has single bonds, like C to C, you know, single bonds. Then the unsaturated one, you know, probably in the structure you find a double bond somewhere of C to C. Now the empirical formula for saturated fatty acids is you know, it's CN H2N O 2. You must know that. But now the N in this case to represent, you know, the number of you know, your carbon atoms, like that, or the number of your atoms in that. So the simplified version that you can just talk about is like this is your fatty acid, you know, like that. You know, this is the head and this is the tail, like that. It's just a straight chain with, you know, carbon to carbon single bonds. Then we've got an unsaturated one. Now an unsaturated one, okay, let's just talk about unsaturated ones for a while. Okay, for a minute. Unsaturated, now unsaturated, we said they've got a double bond. So I find that their structure will have, you know, the head there and probably the tail, like that. Now look at the structure. There'll be a kink here. Now this kink comes because of the double bond. Now the empirical formula for an unsaturated fatty acid with a double bond, or with one double bond, is CnH, 2n minus 2 O2. This is one that has one double bond. Then the one that has two, will say, it will be Cn H2n. Instead of minus 2, we have minus 6 O6. Let's also do the one that has 4. What about the one that has 4 double bonds? So it will be Cn H2n minus 8, and your O2, like that. So that's what you are supposed to know about some of these fatty acids. They are composed of a long hydrocarbon chain, or in that case that one is called the tail, and it's a nonpolar one. Then you also have a carboxylic group, which gives fatty acids their, let's say, acidic properties. And so if a fatty acid has a single double bond, or a single double bond, it will be called a mono unsaturated. If it has if it has more than one, it will be called a poly unsaturated fatty acids. Now, some of the common fatty acids that we can talk about is we can talk about what we call stearic acid. Okay, then you can also talk about what we call oleic acid. So some of the formulas, like the formula for the stearic acid, it's C17 H35 COOH. Okay, you're not supposed to master this formula, but you can just know, like, okay, this is just coming from the general structure of these fatty acid. Okay, now you should know that unsaturated fatty acids are slightly more abundant in nature than saturated fatty acids, and these ones usually find that they're almost found like everywhere, and compared to unlike saturated fatty acids. Now, long chain hydrocarbons of fatty acids, they usually say they are efficient energy storage more than carbohydrates, and usually if you got fats or lipids, they usually yield the maximum amount of energy when you oxidize them. Now let's talk about what we call a triglyceride. Glyceride just to mean a fatty acid, or a lipid. Tri just to mean 3. So it's called a tri because it's made up of one glycerol molecule, or an alcohol. Glycerol is an alcohol. Glycerol, it's one glycerol molecule, and now this is connected to three fatty acids, like that. So let's try to draw this just to put context to it. If you have let's say these are carbon atoms. Let's say, okay, this is a structure for we are saying it's an alcohol, so it has a lot of hydroxide groups. Now we're saying this is combining with 3 fatty acid chains. So an example of a fatty acid, okay, this is let's say HO this side, and let's say this carboxyl group is connected to this hydrocarbon chain, and let's also have another one. This is just connected to that, let's say like that, and this is also another fatty acid like that. This is also connected like that, and this is another fatty acids. So these are fatty acids. Now this is the glycerol, glycerol molecule. Now what happens is during what we call esterification, your hydroxide on the glyceride molecule or the glycerol molecule will react with the OH, only the OH on the fatty acid, and that will be released as water like that. So even in this case, this one will go and react with the OH there. This one will go and react with the OH there. Okay, so what you form after this happens, you form a molecule that is let's say okay, we've got hydrogens on top. Okay, so this can be connected to hydrogen, then there's a chain like that. This can also be connected to the carbon like that, and there's a chain like that. Same here, this is connected to a carbon, this carbon is connected to an oxygen, and a chain like that. So now the thing that you formed here is called a triglyceride. It's the one that we are calling a triglyceride, and the bond that formed is called an ester bond. So now for triglyceride, the one that are made from saturated fatty acids, because we've said it's one glycerol and 3 fatty acids. Now we've said fatty acids, they can either be saturated or unsaturated. Now it means the triglycerides, they can also be in 2 forms. You can have a saturated triglyceride that comes from saturated fatty acids. Then you can also have the one that is unsaturated. So in terms of the structure, the one that is saturated, it will just be the polar head and your hydrophobic tail like that, just in a straight form like that. However, on the other hand, the one that is unsaturated, because maybe it has a double bond, because of a double bond, the structure won't be like linear, because probably of the double bond that it has. So this, I thought of mentioning that. It's very, very important. Now let's talk about what we call phospholipids. Now a phospholipid, we say, is just we're talking about phosphor. Okay, phospholipids. Now a phospholipid is a triacylglycerol in which one of the hydroxyl group is a glycerol, and this glycerol is esterified by a phosphoric or a phosphoric acid rather than by a fatty acid. Now earlier we saw that for you to have a triglyceride, we said, a glycerol molecule, one glycerol molecule has to, combine with 3 fatty acids, just as a reminder. But now for phospholipids, it's different. So the glycerol molecule in this case will be, will be combined by what we call phosphoric acid. Phosphoric acid. So that's how they are different. So when there's esterification, and this esterification is between a glyceride and 3 fatty acids, it's called a triglyceride. But now when there's esterification between a glyceride and a phosphoric acid, you form what we call a phospholipid. Now phospholipids are very complex molecules, because they'll be made from fatty acids. They'll be made from glycerol. They'll be made from phosphates. For you to have that phosphoric acid, phosphate. You can also have a large polar group on a phospholipid. Now because we're saying they have a large polar group, you see that phospholipids they will have some, they'll be soluble in some of the polar solvents. Now one thing that you should know about phospholipids is they form the basis of all cellular membranes. Now this is very important, for it to have the cell membranes like that. It's because of these phospholipids, because they'll control what comes in and goes out of the cells, about the structure of the cell. So phospholipids, they play a very vital role. When you cross over, you start talking about layers of the cell membranes, such as phosphatidylethanolamin, all those kind of things. Those are some of, because of these phospholipids. Then let's talk about the last part, what we call waxes, another form of lipids. Waxes. Now what are waxes? Now waxes are esters of long chain alcohol with a long chain fatty acid. So an example of a structure that I can give, let me say this is an alcohol. It's connected to this, let me say, okay, let me put it like that. Okay, then we are combining this alcohol with let's say a fatty acid. And let me just draw something like that. So this alcohol, the H on the alcohol will react with the OH on the fatty acid, and you form what we call a wax. Now the formula will be something like this, and let's say this is your hydrocarbon chain, and on the oxygen like that, and another hydrocarbon chain like that. So it's very important that we've talked about all the lipids that you're supposed to know. Your fatty acid, your simple lipids, your complex lipids, and we've also classified them, and we've talked about some of their key differences. Thank you all, and we'll see you in the next session.